Okay, hi everyone, and welcome to this beginner level course on Introduction to Database Management Systems and SQL. So my name is Pratik, and I will be hosting this series. So before we get started, just a reminder that this course is being brought to you by the Launchpad initiative by Newton School. So you can go to the Newton School site. The link to that is given in the description here. Once you go to the Newton School site, you can sign up if you are a new user, or you can log in if you're already an existing user. You should be redirected to the dashboard, and this course you can follow it in from the Newton School site as well. So if you go into the tracks, the Launchpad tracks, you will see the course Introduction to Database Management System in English. You can apply for this course here. The added benefit that you get by registering for the course from Newton School site is that along with the videos that we are doing the explanation, you will also be getting doubt clearing session, you will be getting quizzes, and you will also be getting daily assignments to help you keep track of the course better. So with that, we shall get started with today's course. Okay. So just a small disclaimer before we get started that all the views and the opinions that you're seeing in the webinar, they all belong to me. They do not represent the views of that of my employer. So quick look into the agenda as to what we will be learning in this upcoming videos about the database management system and its basics. So initially we will be looking into some theoretical courses, and that is today also mostly we'll be looking into the basics of database management system. Once we know what exactly is a database management system and why it is needed, what are the importance of it, we will be going into modeling. So modeling is something that you do to initially, whenever you have to design a database, you have to design an application. So when you have to see that what are the entities, what are the tables that you need to put into your, what are the that you need to use, that's what the modeling is about. So it's like modeling the entire database. After that, we'll start off with some SQL basics. That is some basics of SQL. That is what exactly SQL stands for. What are the uses of SQL and what you can do with SQLs. This will mostly be a practical class about SQL. Then we'll be looking into SQL queries. So there are a lot of, and there are quite a lot of SQL queries that we'll be looking into. We'll be going into depth of each of those queries, how they work, what are the parameters that they accept, what are the optional parameters, what are the mandatory parameters, how we can refine them and stuff like that. So we will be doing 3 videos on the SQL queries itself. Once that is done, we'll be going into some advanced concepts. So the first advanced concept that we'll be going into is schema enhancements. So the schema that you have defined for a relational database for SQL, you can actually enhance it by reducing the redundancies that you have there. So we call them as a normal forms like the 1NF, 2NF, 3NF and stuff like that. We will be going into details of it, how to define the existing schema that you have created. Then we'll be looking into another advanced concept called hashing and indexing, which is again very important, especially if from a database administrator perspective, if you're looking at improving the performances of your databases, indexing can do wonders for your database. So we will be looking into what exactly indexing is, how it works, and how you can enable it in SQL. And as the last video series, we'll be looking into JDBC. So JDBC is one of the ways of how you can connect your SQL databases to your Java application. So we'll be writing a very simple Java application and we'll be writing a database. Then we'll be connecting the Java application to the database and we'll be pulling data from the SQL database into the Java, and we will be using that data to do some operation in Java. So that's one of the another advanced course that we'll be doing. So today we'll be starting with the first module, which is the basics of database management systems. So before I get started about exactly what is a database management system, there are certain basic terms that we need to get us familiarized with, and that we need to articulate them, or that we need to pen it down. So first thing is, what exactly do you mean by the term data? So data essentially means it is any fact which can be recorded and has got some implicit meaning, which means that anything that you see, like for example, you're watching a movie, the name of that movie, or let's say you've gone to a site like Amazon.com and you're trying to buy a product, then the name of the product, the description of that product, the price of that particular product, these are all data. Like let's say you're going into a school, or you're going into you're looking into a university, then all the names of all the students, what are they? They are data. The marks obtained by those students, that's also data. So everywhere that you look around, it is all filled with data. So any fact which you can record, that is which you can keep a record of, which you can keep track of something like your credit card information, your names, stuff like that, they all can be termed as data. Now coming to the term, what do you mean by databases? So if you collect a data, that is you keep this related data in one place, that becomes a database. So collection of related data, that becomes a database. For instance, let's say if you are going into a site like imdb.com. So what does imdb.com does? imdb.com shows you the names of some movies, the cast which is associated with the movie, some description about the movie, and a lot of rating information and a lot of comments out there. So all these things are data, right? That is the name of the movie, the description of the movie, the comments, the stars, the casts, and everything that you're seeing there. Those are all data. Now, these are all related data in the sense because all this data, they are trying to describe a certain workflow. That is this in IMDb, like so. What does IMDb's main workflow is? That is you go there and you can get to see the movies and you can get to see the ratings and you can get details of that movie. So for that particular workflow, to achieve that particular purpose, that is to go and see all the movies names and the descriptions and the cast, if you're keeping all the data in one place, if you're collecting that related data in one place, that becomes a database. And how can you represent a database? You can represent it in multiple ways. So you can take a simple Excel sheet, and in that Excel sheet, you can keep all this information. That also becomes a database. Like for example, let's say you're running a startup. And in a startup, you want to keep track of that every month, how much product you are selling and how much profit you are making, profit or loss, whatever it is. So what you can do is you can simply open an Excel sheet. For each month, you can say, okay, these are the products which has been sold. This is the amount that we have collected from the product. This is the amount which we had to pay for building those products. And so this is the profit or the loss that we are having. So in that Excel sheet, you can do it for month by month. You can keep this information. You can keep this data. Then what that Excel sheet becomes, that Excel sheet becomes a database for that particular startup, for that particular company. And everywhere that we look, all websites, all software applications, everywhere where we look, we see databases everywhere. For example, if you go to something like Amazon.com, obviously they have got a list of products. Every product has its price, they have its description, they have its shipment information, they have the vendor information. So all that data, they are kept into the Amazon database. So Amazon also has got a database in that sense. If you go to something like Netflix, obviously it contains a list of movies, description for that movies, the actual streaming, the actual content of that movie. So they also need to keep it in some sort of a database. You have got Facebook, which contains all the posts, all the users, their information. WhatsApp, so when you're doing it in WhatsApp, it's probably your chat and things are stored in an encrypted format, but they are stored somewhere. They are stored in some sort of a database. So every application that we look at, every software that we look at, they are all having some sort of a database. Now that statement is not an exclusive statement, that it cannot be said that every application has a database. You can have applications without any database as well. But if you're building a kind of a B2C kind of an application, or if you're building a consumer related application, what do you need to store data? Basically, any application which has got the requirement of storing some information, that must have a database. To look into an example of some database, let's assume that this is a database for a particular university, for a particular college, where you need to store the students who are present there. You need to store how much marks they are getting, and you also need to store what are the courses which are offered in that university, and which student belongs to which course, or which student belongs to which department. So if I want to maintain a database like that, then what are the things that I need to do? I need to first keep a table or some format where I need to keep all the student names and the departments. So that becomes probably one entity set. That is, it is a collection of students. So I can keep it in a table, I can keep it in a file, I can keep it in a JSON object. It doesn't matter how I keep it. But logically speaking, you need to have a place where you need to store the names and department and roll number of all the students. Similarly, you need to have another table. Physically, it can be stored as a file, JSON file, it doesn't matter how. Physically, no matter how you store, but logically, you need to have another table which will contain all the courses which are offered and which department offers it. Like for example, object-oriented programming is offered by the CSE department, steam engines is offered by mechanical department, artificial intelligence by the CSE department, DBMS by the CSE department. So that information you need to store somewhere. Similarly, which student is scoring how much marks, so you can store with the roll number of the student and how much CGPA the student is storing. Like the student with roll number ID 1 is getting an 9.48, another student with some roll number, let's say 4, is storing 7.5. So physically, so logically speaking, you need to store information like this. Now, how we can store that information physically, that depends actually on the database that you are trying to store. If you're keeping a database like a relational database, then you need to store it in tables. If you're having a NoSQL type of database, like something like Cosmos DB or DynamoDB, then this will be stored as document. We will actually be going deep into it. We will see exactly how you can store databases and everything. But for now, this is just an example to show you logically how data can actually be stored. Now that we know what is data and databases, we also need to know what is a database management system. So database management system, so whatever you're seeing on the slide in front of you, that has been taken directly from a book called Fundamentals of Database System by El Masri and Navate. So what it says is program that enables users to create and maintain a database, general purpose software system that facilitates the processing of defining, constructing, manipulating, and sharing databases among users and applications. Now, this is a very wholesome definition that you have for a DBMS or a database management system. But talking in very simple terms, a database management system is nothing but a software which enables programs and users to connect to a database. So like the last example, we saw that we have got so like 3 tables, and these tables are stored somewhere, I said, right? In physical, some hard disk, somewhere this data is stored. Now you need to have a user who is accessing this database. Like for example, let's say the dean of the university comes, and the dean of the university needs to check, okay, how many students are enrolled in the university at this point of time for this particular department. Like let's say the dean wants to know in the computer science department, how many students do you have and what are the marks that they are studying. So you have got the user somewhere, that is the dean of the college, who wants to see some information. That information lies in the physical hard disk somewhere in some format. So the software in the middle, which is allowing you, which is enabling a user to connect to that physical information, is what is the database management system. That is what is lying in the middle. That is what we mean by the DBMS. So if we now going into the definition a little more deep, there are things like it is a general purpose software system that facilitates the processing of defining, constructing, manipulating, and sharing databases. So what it means is your database management system, which is a software which is lying between the user and the physical hard disk where your data is located. It is not only allowing you to connect it, it is also allowing you to create the databases. So let's say now it is not the dean, but it is, let's say, the software developer who is actually developing the college application. Let's say that user now wants to create some information or create the database. For that purpose also, you need a database management system. So this software will allow you not only to get information and see the database, but also create new database as well as modify the database. So what do we mean by the modify the database? Like for example, here we are seeing only 5 students have been given as an example, right? But what happens in the real world scenario is that every year, after every 2 semesters, new students join, and a bunch of students, they graduate. So they are going out. So that means every year you need to insert information into this table, and you need to delete some information out of this table. The same thing can happen for the courses table also. Probably every semester there is a review meeting and new courses are added, and old courses which are not required anymore, or which have become pretty old anymore, they are deprecated from the databases. So which means you need to modify the database as well. So even for the modification purpose, you need to use the database management system. So if you want to create the database, modify the database, or simply view the database, you need a database management system. And one more definition about database management system, which says the last line, which is the sharing databases among users and applications. This is also very important. There can be multiple types of users who can come and see and see the database. Like for example, when the dean comes, the dean can come and see all the students who are available. Even one particular student can also come into the database and try to see, okay, what is the mark that I am getting, that what is my CGPA. So which means there can be multiple users, multiple types of users who wants to see the database. So means the same database, they need to be shared among multiple users. But one thing you need to keep note here is, not every user should have the privilege of seeing all the data. Like for example, why should a student who belongs to the CSE department be allowed to see the marks of student from a different department, from the mechanical department, let's say? They shouldn't be allowed to see it. So when a student comes, we should have proper security restrictions on top of the database, which will only allow that student to see marks of his own department or his own marks. But when the dean comes in, the dean of the university comes in, the dean can see marks of all the students, regardless of which department that student belongs to. So for the dean, those particular security restrictions need to be removed. So means the same database, the same physical information which is stored in your hard disk. When different users are coming, you need to show different types of information, or you need to have different security policies for each of these users. So this is where database management system again comes into the picture, which allows you to share the database among the users, but it gives you proper security, or it allows you to put proper security protocol in places to ensure that you, depending on the type of user who's coming to the system, they will be only be able to see that type of information. If we have to see a diagrammatic representation of a database management system, this is exactly how it looks like. So this is what we've been talking about in theory, but diagrammatically, this is what it looks like. So you have got a user who wants to see some data. So right at the top, you have got the user who's trying to see some data, and the user actually generally doesn't try to see the data directly. They try to do it via client application, via some software actually. So for this example, let us take the example of an e-commerce website. So for an e-commerce website, like let's say Amazon.com. Now, when you've got Amazon, let's say when you're logging into something like Amazon.com, the users are not really seeing the data directly, right? They are seeing the data via website. That is all the product information, the order history and everything. They are seeing it via an application. What is the application here? It is a web application called Amazon.com. So the users do not directly go to the database management system. Rather, they go to some client application, some software, and then that software goes to the database management system. So in the case of an e-commerce website, things like Flipkart.com, Amazon.com, these are the web applications which the users are visiting. Now, the actual data is stored somewhere on the physical hard drive. That's the physical data. Now, you don't want the direct physical data to be accessed via the client applications. And to access the physical data, we have the database management system in the middle. So the client application, which is a web application in our case, something like Amazon.com or Flipkart.com, they will be talking to the database management software, the DBMS in short. They will be giving their queries like, hey, I want to, for example, let's say the user wants to see, tablets, like all tablets that are tabs which are available with a particular range, like let's say the price range between 10,000 rupees to 20,000 rupees, the user wants to see that information. So what the client application, that is Amazon.com's website, is going to do is, it is going to talk to the database management software, and it is going to tell, hey, go to the physical data where the actual data is stored, show me all the tablets which lies within the range of 10,000 rupees to 20,000 rupees. So that is the query that the client application is going to give to the database management software. So the first thing that your DBMS is going to do is, it is going to process the query. Process the query means, so again, like query processing is actually a huge thing in itself, like query trees and optimization and stuff like that. So I'll not be going into very details of it. But from a 10,000 feet view, if you want to understand about processing the queries, it is about understanding what the user, or understanding what the client application wants to see, and translating that into the way data is stored in the physical system. Like for example, let's say in the physical system, the tablets are stored in one particular location. And even in that particular location, let's say you have sorted the tablets and you have said that this sector will contain all tablets belonging to this price range. You can have another sector which says, I'm talking about your hard disk itself, that in this sector we will have tablets of this particular cost range, another sector for another particular cost range. So when the DBMS is seeing a query which says that I want all the tablets at particular this range, what will the query do? It is actually going to understand, okay, since you're looking for tablets, I need to go to this particular sector. And since in that sector is also subdivided into price range, based on the price range that the user has given, what are the sectors where my data is located? This is a very brief example of what exactly is meant by processing queries. But query management and query processing is in itself a huge topic. So once the query has been processed, what we're going to be doing is, we're going to be going to access the actual physical data, get the data from the actual physical location in whatever format they are stored, manage it into the format which the client application is expecting, and then give the data back into the client, to the software, the client application. And that's how the DBMS works. The one very apparent question that can always come up when you're seeing a diagram of this sort, or when you're trying to understand about DBMS, is that what would have happened if DBMS was not there? Does it mean that why can't the client application directly talk to the physical data? So the answer to that is, it is theoretically possible. That is obviously whatever client application you're writing, whatever software you're writing, that directly talk to the hard disk where the actual data is stored. It doesn't really need to go via database management system. Database management system is nothing but a broker in the middle, right? They can always do that. There is no problem in that. But the issue that is going to happen is that is your DBMS is giving you a lot of abstraction. It is abstracting the client application and the user from a lot of unnecessary details that your application should not be aware of. Like for example, when I'm talking about the physical data. Now, in a real life scenario, the physical data is actually not going to be stored in one device or one system. The physical data will be stored in multiple devices. Because if you think of something like Amazon.com, with the number of products, there are millions of products out there, right? And each product has its own details, its historical details and stuff like that. There are so many users, hundreds and thousands of users who are signing in, their sign-in information, their order information. That's a huge data. We are talking probably in terms of terabytes and petabytes here. So when you're talking about this much amount of physical data, it is impossible that this data is stored in one particular location. It is stored in multiple locations. And that too, there are fallbacks. Like if one database node goes down, there will be another database node which has to come up. So every data has to be replicated into multiple databases to ensure that business continuity is maintained if the database goes down in one particular region. So the physical data that we are talking about, that itself is a mesh. That is, it is stored in a mesh of network out there. There are so many nodes out there in that particular service mesh, and then some portion of the data is stored there, some other portion is data is stored there, and then the data format also the data is stored in, that might also differ and stuff like that. So all these things is going to happen. So if your client application needs to talk to the physical data directly, it has to know all this information, which is not impossible, but it is an impractical thing to do. That is why we rely on database management softwares in the middle, which can actually understand how the client application of the user needs the data in. It also understands how the data is distributed and stored in the physical format, and then it is going to act as a bridge in the middle. So with this, we get something known as program independence and data independence. What it exactly means is that if ever the format of your data needs to change, like for example, let's say you're storing the data today in a FAT32 system, tomorrow you need to store it in a different system, or the hard disk where you're storing that has got a different formatting out there. Now, if your client application was talking directly to the physical data system, then what would have happened? Every time the hard disk type changes or the hard disk format changes, your client application needs to revamp itself. It needs to change its coding to understand that new file format. But with this process, what is happening? Your database management system will automatically take care of it. Your client application wouldn't even know that the physical data format has changed. That's a major advantage that you get. Another advantage that you get is a program independence, which means tomorrow if the client application needs to change, that is, it needs to, let's say, show some other information, or doesn't show all the information but extract certain information, select certain information, and do some operations like that. In that situation also, the way the physical data is stored, that need not change. The physical data may contain 100 attributes, but the client application only needs 10 attributes. It's a database management system in the middle which is going to do that for you. But had your client application been directly dependent on the physical data, achieving something like that would have been a problem. Now, another major advantage that we see in a database management system is a three schema architecture. Three schema architecture actually means, that is, and by the way, before you go into three schema, just a little bit about what exactly is meant by schema. So schema is a description of the data. It is not the actual data, it is a description of the data. To take an example, we'll go back to the database example that we saw with student courses and CGPA. So see, the student actual roll numbers, the actual student names, the department information, course information, that is the data. But the schema is describing how the data looks like. For example, it says a student table is going to contain a student roll number, student name, and department. So the schema of the student table is student roll number and an integer. It will contain a student name, which will be a string, and it will be a department, which will contain, let's say, 5 or 6 characters. Similarly, if I come to the CGPA table, so the actual data, the actual student roll numbers and actual CGPA, those are the data that is stored. But the description of the data, that is what is exactly in that table. So in that table, you have got a student roll number, which is an integer, and a CGPA, which is a 5 float or double. So that description is a schema. So schema describes how the data looks like. It doesn't describe it is not the actual data, but how the data looks like. It is also known as metadata in some situations. So coming to the three schema architecture, the reason why three schema architecture is actually very, very important here, or rather the concept of it is very, very important, is What it essentially means is that the data is stored in the physical device. That's the actual data it is stored. But it is represented in three different formats, in three different schemas. So first one, or if we go right from the bottom, is the internal schema. Internal schema means the physical strategy. That is the physical strategy of how the database is actually stored. Like that is in which file system you're storing. Are you storing it in a FAT32 system? Are you storing it in a NAT system? Are you storing it in a Unix system or whatever? That how the file system is described, how the in which operating system you're storing, how you're doing the clustering of the data, how you're indexing the data, how you're hashing the data. All that information is the internal schema of the data. It's also known as that's a physical level. It's also known as the physical schema of the data. Now, the physical schema of the data is considered about the physical strategy of how the data is stored. But conceptually, that is not how the data is stored. Like, for example, again, if we go back to the example, conceptually, the data is stored among three different tables. One table with students, one table with courses, another table with CGPA. That's how conceptually, logically, that is how the data is stored. But physically, this data may be stored in a different way. Like maybe each table might be stored in a file, and that file may be distributed among multiple nodes of having FAT32 system and stuff like that. That's a physical strategy. But conceptually, those are just tables, three tables. So that is a conceptual schema. And now comes the external users. And I think probably we discussed about this as well. If the dean comes, the dean can see all the information. But if a particular student comes, the particular student can only see the information pertaining to that student's interest. Like for example, if I am a student of CSA department and I go to see my marks, I should be able to see only my CGPA. I should not be able to see CGPA of my friends belonging to a different department. So every user gets to see a different version or rather a different format of the data, a different schema of the data. That is known as the external view or the external schema of the data. And this is one of the major advantages or major features that you get in a database management system. What the same physical data can be represented in three different schema: internal schema, conceptual schema, and external view, or the external schema. Based on at which level you are and what type of user you are, you get to see that particular schema. Like for example, if you're a database administrator, you are the one who's administering that particular database. Then you will be working with the internal schema. You will be responsible for how the data is actually stored in the physical device. If you are a programmer or if you are a database designer, you will be more concentrating on the conceptual schema. That is how is the conceptually the data is stored, and based on that you need to write your programs and write your code on top of it. And if you're an end user who's coming into the application to see their data, then you are an external user. So you will be concentrated only on external view or the external schema. And having this external schema, the advantages that you are getting is you get logical data independence and you get physical data independence. What it meant by this is, so conceptually, if you are changing the data, like for example, conceptually, let's say today we are seeing conceptually everything is a table. But tomorrow, let's say I said no, everything is not a table, everything is a document. That is, if you move away from a SQL database into a NoSQL database. So in that sense, if your conceptual model is actually changing, that doesn't mean that the external model has to change. That is, externally, a student is able to see his marks, his or her marks. But how conceptually the data is stored is a table or data is stored as a JSON object, it doesn't matter. It shouldn't be immaterial for that. So that is what is meant by logical data independence. And taking that concept one more level deep, we have got the physical data independence, which means in the physical layer, if the way we are storing the data, that changes, that should not affect the conceptual model. So conceptually, we are storing tables. Now the table gets translated into indexes and it might get distributed into multiple nodes and multiple servers. That is fine. So tomorrow, let's say we say that, hey, well, there is a lot of data that is coming in. So physically, we cannot store the data in one node. We need to partition that data. It's known as sharding actually. We need to partition the data and keep that same data into two different servers. So physically, you're changing the way the data is stored. But conceptually, you're still seeing a table only, right? It's just that the table physically has been split into two different servers. So physically, even if the database is changing, conceptual model does not change. This is what is known as the data independence. And probably this should be the only reason as to why we should be using a database management system and we should not be giving our software or application direct access to the physical server. With that, I'm going to take a small pause and I'm just going to take a look into whether there are any questions so far or not. I do not see any questions. Someone has said hi. Hello. So if there are any questions, I would suggest that you can put them in the live chat. Or what else you can do is you can actually put that as a comment in this particular video. We can reach out to you. And if you have registered to the course, then there is a doubt clearing session where you can actually go ahead and ask your doubts there. So there are various ways how you can ask questions. But yeah, if you have any questions right now that you want me to tackle, you can put it in the live chat directly. Okay, all right. I shall be moving on. So next we'll be talking about what are the advantages of database management system. We kind of actually saw already what are the advantages. That is the main advantages that we saw was in terms of interdependence. Now we'll be looking into some of the other advantages. Those are not really very obvious. First one is controlling redundancy. Very important. And especially if you're using SQL, that's one of the salient points possibly you can say. So redundancy means duplication. So with DBMS, you can actually control the duplication of data. To give you a fair idea of what it exactly means, let's say you want to store students information and you want to store what are the courses that one particular student has undertaken. So let's say let's say I'm from the computer science department, so I have taken courses like database management system, artificial intelligence, and object-oriented programming. Similarly, there might be hundreds of students in the CSE department who might have taken the same courses. That is artificial intelligence, database management system, and object-oriented programming. So now if you want to simply visualize how the data is going to be stored, what you're going to be thinking is you've got a student object somewhere and the student object has got an array of courses. And you've got hundreds of student objects. So there will be hundreds of such objects and each object is going to have an array. Now, what is the problem with this mechanism? The problem with this mechanism is the courses, which I talked about, those three courses, which are common courses, that has been duplicated in all the student objects. So if there are 100 students, that has been duplicated 100 times. That is redundant data because you don't need to really keep the data in 100 different places, right? We should be able to keep the data in only one place and your student object should be able to refer that information from there. And that is what DBMS does. Database management systems allow you to control the redundancy by keeping relationships and stuff like that. We'll actually see that when we go deep into our DBMS, we will see how we can control the data redundancy and stuff like that. Next thing is data integrity. Again, this actually comes from data redundancy itself, but data integrity has its own advantages. So what is meant by data integrity is, so let's assume that let's take the same example of where we have taken a student and the student has got multiple courses and each course has got an instructor. Like object-oriented programming has an instructor, then the instructor means the professor who is actually going to be taking the classes. Object-oriented programming has an instructor, database management, DBMS has an instructor. So everyone there is an instructor. What data integrity tells you is, let's take a sample where let's say one of the instructors has fallen sick in the middle of the semester, so the instructor has to be replaced by an alternate professor. So what it means is that when you're storing this information, that is every student has a list of courses and each course has got an instructor. So if you're changing the instructor for one of the courses, which is let's say object-oriented programming, you need to change this information in 100 different places because there are 100 students. And each student has got a course array and in that course array has got an instructor. And if you, let's say, forget or because of a system error or something like that, you are not able to update that information in, let's say, two of the nodes, in two of the student objects. All the 98 of the student objects were taken care, but two of the student objects were not able to take care. You are not able to, update that information. So what is going to happen? Your data will be inconsistent in nature. That is, data for those two students will be incorrect. So the data does not have integrity. So one of the other things which a DBMS must provide is data integrity, which means that if you are updating a data into, if you're updating one particular entity, wherever that entity is referred by whichever entity, they should all get automatically updated. And when we actually talk about schema refinements, like 1NF, 2NF, or 3NF, these are places where actually you can reduce the redundancy and improve data integrity. Another example of data integrity, let's say every course now has got some books. Okay, that is every course has got some books which are referred there. Now, what happens? Let's say you suddenly say that this course is not needed anymore. Like for example, let's say you are doing a course on let's take over something which is already deprecated. Let's say you were doing a course on computer vision, and the course that we were doing on computer vision, that was actually, it was referring to very old computer vision concepts and everything, and suddenly you want to delete that. You want to delete that particular course. Now what will happen to the books which are stored for that particular course? they will continue to remain there. And if someone asks who does this book belong to, they will say this book belongs to a particular, it belongs to a computer vision course. The computer vision course itself doesn't exist anymore. So again, that is an issue with data integrity, that your data is not proper. There is inconsistency again in your data. So that is again another thing that which RDBMS or database management system provides, things like differential integrity and things like cascade delete and stuff like that. We'll go into it later. Efficient query processing, obviously major advantage of database management system. If your applications are directly calling a physical systems, then obviously it doesn't know where data is stored in which physical devices and stuff like that, and which is the best way to access that particular query. But the database management system knows that information. It knows how physically the data is distributed. So whenever you're giving a query, it can break the query into small queries, which can give you maximum efficiency. Backup and recovery, obviously if you have got a database created and then you need to recover the database, like for example, so let's talk about backup first. So backup means that you have the database in one location, all the data, but tomorrow if there might be an issue, like let's say there is a disaster, natural disaster, or there is a hacking or something like that, because of which your database gets compromised. So in that situation, you need to bring a backup or a copy of the database, right? So that is known as backup. Next thing is recovery. So recovery actions can mean a lot of things. So one type of recovery is obviously just taking or restoring the backup. That can be a recovery. Another recovery means can happen like, let's say there is a hack or something like that in your database, because of which your information has been compromised. So the last checkpoint where the data was correct, you can recover the data from that particular location. Those are called checkpoint recovery. Security, definitely it gives you added security. We talked about that dean and student, where the student can only see the student's marks and not the student's friend's marks, but the dean can see all the marks. So those are security where based on the type of user who's logging into the system, you need to only show different type of information. Transactional support, again, transactional support, what it meant by that is, if you're trying to do, let's say three operations in the sense, let's say whatever, like for example, we will take our example of the books and courses. Like let's say you are deleting a particular book or you are deleting a particular course. So when you're deleting a particular course, you not only need to delete the course from the course table, but you need to go to the books which are related to that course and delete those books as well. So you're doing multiple operations. You are first deleting one course, and if there are, let's say, 5 books associated with that course, you need to go and delete 5 books as well. So you're doing in total 1 plus 5, 6 operations. Now a situation may happen. Let's say you've done the first 2 operations, and after that, whatever your database is stored, whatever server your database is stored, there is a sudden power loss in that server, or there is some natural disaster because of which that particular server goes down completely. So what happens in this situation? You have done only 2 updates. 4 more operations are pending, but before you could do those 4 operations, your system has gone down. So now how your data is going to look like? It is again going to lose integrity. There is again going to be, you're again going to introduce inconsistency into your system, where probably, let's say, one of the book was deleted and the course was deleted, but there are 4 more other books which were not deleted belonging to that particular course. What transaction allows you to do is, if you are doing certain operations like this within a transaction, then until all the operations are complete and you say that this transaction is complete, these changes won't take effect in the database. So it means that if I'm trying to delete, let's say, book number 1, book number 2, and before I go to delete book number 3, 4, 5, and 6, suddenly the server goes down, and you were doing these operations under the umbrella of a transaction, and so the transaction is not completed at this particular stage. So your physical data is going to remain intact. That is, those codes will not be deleted. Those books which you had initially tried to delete, they will be recovered back. So those books and the codes will continue to remain in the table. But if you're able to do all the 6 operations, that is delete the 5 books and that one particular course, you can tell the transaction, okay, I'm done. Then in one shot, all the changes which you had said will take effect in the database. So we'll be looking into, in the advanced concepts, we'll be looking into transaction, we'll be looking into something called asset properties of a database. We will be going into it in a little bit of details. And another advantage is obviously multiple schemas, which we saw in details in the last slide itself, where we talked about the internal schema, conceptual schema, and the external schema, how the same data can be represented in multiple formats. We could talk a little bit about the roles or the types of users who are present in a database. So you have got the database designers who are actually designing the databases, the end users who are coming to the database for some particular queries, programmers or software developers who are actually developing applications which depends on the database, and we have got DBS, which are database administrators, who are actually administrating a particular database. So the physical. So when we're talking about the internal schema and everything, where actually the database is stored in the physical format, it's the duty of the DBS. The database administrators are the ones who are actually going to be working on it. The database designers are the ones who design the database, the conceptual model of the database. So they will be mostly interested in the conceptual schema and the internal schema. The end users will be interested in the external schema. Programmers both in the internal schema and in some cases the conceptual schema, because they need to understand how the data is conceptually done so that they can write programs or software on top of it. And DBS mostly into the physical schema and also some interest in the conceptual schema. So these are the different types of actors or the people who can come into a database, and you need to entertain them. And DBMS needs to have a special provision for each of these users. Now that we know what exactly is the DBMS, we shall look into what are the types of database management systems that you can have there. So you can actually classify database management systems via multiple parameters. Like you can classify them as whether the database management system is currently valid or it is a legacy kind of a database management system. But one of the best ways, or one of the most practical ways of how you can actually classify a particular database management system is the model. That is how the database management system holds the data. And I'm talking about the conceptual schema here, mind you, not about the physical schema. Like conceptually, how the database management system stores the information. So first type of is called hierarchical DBMS. Hierarchical DBMS means it is going to store the information in the parent-child relationship. So you have got a parent node which contains some data, and then that parent has some child which contains some information. Like for example, let's say you are trying to store the information of a family structure. You are trying to store a family tree. So first you are going to be storing the information of, let's say, the grandfather and the grandmother of the family, the patriarch and the matriarch of the family. Then they will have children which will be like the father, mother. That can be other uncles and aunties into the who will have a child relationship with the parent relationship. And then obviously then your generation is going to come, like your parents, then your cousins, your brother, your sisters, and stuff like that. So if you're storing the information in a hierarchy like this, then that becomes a hierarchical type of database management system. And some of the examples was that in IBM you had a database called information management system, which used to store hierarchical database. Then the Windows registry, if you're using a Windows OS, the registry information that is stored in the hierarchical format. So IMS, Windows registry, these are examples of hierarchical databases. Hierarchical databases are not used so much anymore actually. This was one of those earlier concepts of storing database, but people soon realized not every type of data can be modeled into a parent-child relationship. That's the reason why hierarchical databases are not in use so much. Windows registry still uses hierarchical database because that data model is very specifically fitted for a hierarchical model. But most of the other scenarios, not everything can be fitted into a hierarchical model. So since things were not being able to fit into a strict parent-child relationship, people said, okay, why not give everyone access to everything? That is, every node can be related with multiple nodes. That is what is known as a network model. So you have got something like a RIMA database manager, which uses network model. You have got IDS, which is using network model. So network model is a little bit of improvement on top of the hierarchical database, where every node can have relationship to multiple nodes. Again, network models were also, since they were an improvement over the hierarchical model, they were a little famous. But then soon people realized not every node can have a relationship with every other type of node. The relationships may be very strict in nature. Like for example, the student table and the course table that we saw. The student and the course table has got a very specific type of relationship. Then the course table and the marks table, the student table and the marks table, they have a very special type of relationship. A teacher table and the course table might have a special type of relationship. A teacher and the student table will have a very specific type of relationship. So what network model was not allowing you to do was, it was not allowing you to define this relationship. That is, how were these nodes actually related with each other? So that's where relational database management system came into the picture. What the data are stored in table in terms of rows and columns, and these tables are related with each other. You can specify special relationship for each of this table. How we do that, we'll see that later in the modeling class, in the modeling video tomorrow, we'll be seeing that. But that is what relational database management system does. And this is one of the most popular database management system that you have. Things like SQL Server, Oracle, they all support relationship database management system. Another format of database management system is object-oriented programming. database, the object databases. So what object databases does was the way you are storing objects and the relationship between each object in a object-oriented programming language like Java or C# or C++. You are storing that exact information in a database as well. So this the type of database had some popularity. It is still in use. Some places like Gemstone, Tornado. These are some of the databases, object databases, which is still in use. But it is not as popular as a relational database because of database redundancy and everything, which relational database does a brilliant job of handling. So that's why object databases are not that popular, but it is still relevant. There are databases which are, or there are applications which are built on object databases. Next are the graph and the document databases. So these are fairly new. So graph database is like you're storing the information in a graph, but you can specify the type of relationship that you can have in the graph. You can have nodes and edges to represent it. And some examples of graph would be something like Gremlin. You have got Azure Cosmos DB also has got a has got a graph database in it. You have got Neo4j, which is also a very popular graph database. So if your information can be represented in a graphical format, then graph databases makes a lot of sense. Another type of database which is very famous is known as a document database. So here the information is stored in a particular document. One of the most famous document databases that you have today is the DynamoDB, which is from AWS, and Amazon uses it extensively to store information. Other examples of document DB would be Cassandra. Then you have got Azure Cosmos DB, which also has got document APIs. So these are all NoSQL in nature. We'll understand what is a SQL and NoSQL in one of the later videos. But for now, let us just understand that graph and document, they are non-relational in nature, and they do not use SQL language. We will come to this later when we do it. Now that we saw about the types of database management systems, for this particular series of video, we will be concentrating mainly on relational database management system. So relational database management system, as we just discussed in the previous slide, if you are storing relations, that is, you need to store relations between multiple tables or multiple entities that you have in your system, and you want to define those relations, then relational database management system is the best fit for you. So relational database management system, the way the data is stored is data is conceptually stored in tables. So table is nothing but a collection of related entities. So the initial example that we saw with students' courses and the student marks, that was actually our DBMS. That was a relational database management system, because we are storing one table for a particular entity. Like one table will contain all the students, one table will contain all the courses, one table will contain all the teachers, and so on and so forth. So you're storing all the related entities in a particular table. And in the table, you've got rows and column. One row is a particular entity, which means one student's all the information is stored in the row. So that's one row. And columns are the attributes. Attributes means what are the specific properties that you want to store for a student. Like for student, you want a roll number, name, then address, gender, and stuff like that. So that becomes the columns. And tables can be related with each other using foreign keys. This is the main USP or the main salient point of our RDBMS, where one table can be related to other table. And the way we do that is using foreign keys, which we will be seeing in depth when we actually start doing modeling. When we'll be modeling a relational database, we will be seeing that in much more details as to how these foreign keys and everything are maintained. So that's it about relational database management system. So today's video, it was mainly a very back to basics kind of a video where we got to understand what is a database management system, why is database management system so important. We also got to go in depth about the 3 schema architecture, which is probably one of the biggest advantages that you get using a database management system. Then we saw how we can classify database management systems using the type of model, that is the way how the data is actually represented in the database management system. Like if you're representing as a hierarchy, it becomes a hierarchical DBMS. If you're representing as a graph, it becomes a graphical graph database management system. Or if you're representing as relations or as tables, that is the one which is the main interest in this particular video, that is relational database. It becomes a relational database management system. And then we looked into what exactly is relational database management system. Here the data is stored in terms of tables, and the table is nothing but a collection of related entities, and each table can be related to other tables using something called foreign keys. So that's about this particular video. I'll be taking a moment to see whether there are any questions on the live chat. I do not see any questions on the live chat. That's fine. So if you have any questions, if you have any further questions that you think was not answered in this particular video, you're welcome to put it as a comment under the video. And also, if you have registered as per in Newton School site, you can post that question in one of the doubt clearance session, and someone will get back to you with that particular question. All right, so that is about today's video. Tomorrow we will be in the tomorrow's video. We will be looking into modeling, especially into how to model the databases. We will be looking into something called ER modeling, that is entity relationship modeling, and then we'll be looking into how we can model in a relational database. So we'll be doing some practical examples along the way. So hope to see you folks tomorrow. I hope that you enjoyed this session. And with that, I would like to thank you all for joining this session. Hope to see you tomorrow. Thanks, everyone.